I'm Dan, this is Leif, and this is Salor. Salor is a kind of a backronym, if you will. Not necessarily an acronym, but we came up with a cool name and then fit words to it. So backwards acronym. Synchronous, or semi-autonomous liquid oxygen reporter. The whole goal for this was to see if we could predict cyanobacteria blooms in bodies of water. Cyanobacteria is related to algae, but they tend to produce a lot of toxins that can strangle an ecosystem. So if we were to put a dissolved oxygen sensor on this, which we have, and that's the next stage, then we should be able to predict where an algae will bloom. That and the HD camera that's on this can see or gauge the turbidity of the water, how clear or murky it is. So if it's murky, there's a lot of food in the water for the cyanobacteria. Also, we're going to put a sensor on here that measures the depth and the temperature of the water, its compass headings, things like that. This has been no short of a miracle that we're at least this far, because this is largely a kit that was funded by some fish ecology professors from UMass. We had an idea for this project, and we were going to cobble together maybe a toy boat and some motors, an Arduino, get the sensors, and Charlie had taken a few of us from the class to a Maker Faire in the Bronx, and we see this. Charlie goes nuts, says, we have to buy this. We have to get this. We'll figure a way. And he put us together with a couple fish ecology professors, and they said, well, yeah, we can use that. So once we get this thing going, it's going to go over to the Quabbin. It's also slated to go to Christmas Island out in the Pacific to study all sorts of different fishes, mating behaviors, habitats, things like that. So sort of a small class project that's kind of blown up into research projects as well. I'm going to try to continue this with an independent study and a research paper. We'll see how it goes. We are still having some issues. Oh, we've got it up on the screen. That's cool. So that's the cockpit. That's what you would see from the HD camera. Slight delay because there is 100 meters or 300 feet of tether that this is connected to. And what's really interesting is here, what's called just pulled the plug on the home plug. Again, some of this DIY stuff, we're figuring out what needs a little more robustness. Because you'll see here and there where it works well, but you put it into the field, into a practical application, and it'll start to fall apart, or it just doesn't work the way you want it to. That's kind of the nature of these DIY common knowledge projects, collaborative projects, collaborative efforts, if you will. Somebody experiences something and tells the rest of the group. It works, but there's always challenges. I don't know, Leif, did you want to say anything about this? No?
You said a lot.
He was saying a lot. They weren't necessarily good for public speaking as we were trying to get this working. And that's the other, some issues keep coming up where we're trying to calibrate motors to run properly. And they do when you turn it off, and they don't when you turn it back on. Why? We don't know. We're going to get there. We're going to figure this out. But we were just backstage, and Murphy showed up with his law and threw a wrench into everything.
Yeah, right now, we're just waiting for it to boot up. And then we'll be able to just do a really nice, simple flight test.
So the fish ecologists that have supported this are Adrian Jordan, who was here, but he had to leave with his kids, and Allison Roy and Andy Danielchuk. And if I had time, I won't do this, but Andy's right now down in the Bahamas, and he has some footage of bonefish, which are a big recreational fish in the Bahamas. And he's been the first person to actually capture their spawning cycle on film. And so when Andy heard about this, he's like, I've got some great water that's pretty clear. Let's take this open source robot down and let me take some more footage of the bonefish I'm studying. So we were shooting for that, and these guys gave it a great effort. But this whole device came in totally in pieces. and it was about $1,000, even though it's open source and relatively cheap compared to other submarines. And this was a really big effort to put this all together. So I commend you guys for the gallant effort you've been making in this. Are you to the point where it's?
Oh yeah, we can bring flags. We can the camera back up.
Can you start to yeah?
Has it gone underwater yet?
Not yet. I wanted to put this in the water right now, but Charlie said
I brought a tub. We were thinking about it.
if it's gonna fail, not in front of the people.
I was more concerned about just making sure it didn't have any water leaks and not rush it, so that we have a $1,000 piece of equipment get wet. So,
Well,
are you able to show it at all?
why don't you
Yeah,
explain?
we can just so there's already 3 motors in it. There's one for vertical movement up here.
Where's the light? Do you need the light, Steve?
Okay.
Steve, do you need the
And
light?
then there's another 2 in the back for starboard and port motion. And we can just control those through this, which is just in Google Chrome. And it just sends sends the signal through this cord, which is
Everybody wave to the camera. There we go.
We are having, yes? There we go.
The depth is controlled by the vertical thruster. The goal is to get it neutrally buoyant, and because of the seals here holding in air and a little bit in the battery tubes, there's a positive buoyancy. The batteries are quite heavy. The casing, the body, the electronics, negatively buoyant. So the goal is to get it right in the middle there, neutrally buoyant, and the vertical thruster will pull it down or bring it back up.
Does it have any kind of emergency rate where if it's starting to lose all of its battery and it can't contact you, it'll just drop a weight and then float to the top?
No. It's not something I had thought of. But
I can just imagine if something goes wrong when it's down in the quad, but it might be hard to get it back.
I'll just pull it up by the tether.
Oh,
Yeah.
that will never break.
No. Are you related to this guy, Murphy?
Well, I just built many things. It's amazing how many different ways there are for things not to work.
Oh yeah, absolutely. Again, these DIY projects are the best way to figure out how not to do something, or how it will fall apart or not work on you. And the more complexity there is, the more ways it can go wrong, and you learn how to get around that. So it's a continual learning process, which is great. Like I said, I'm trying to turn this into an independent study and using automatic controls and maybe a couple other thrusters, vertical thrusters, to control the stability of it. So you've got an HD camera. If it's out in the ocean, it's going to be currents that are going to be moving it around. You want to try and get it to stabilize. There's a way to, the emergency, oh no, something went wrong, and just have those thrusters shoot it to the top. So thank you for bringing that up. That's a great point. Something I had not thought of, but that's now in there.
So Lake Public Lab, this group is called Open Rove, and they've actually got a website platform, and there are other researchers starting to use these devices. And so one of the eventual goals will be that we'll have a UMass Open Rove site where we're sharing our experiences, and Lake Public Lab, hopefully learning from all the different scientists trying to use this. One of the interesting things that Dan and I were talking about last night is that the people that are building this are now on version, 2.7?
Yeah. There was a
And-
2.5, this is 2.6, and now they're 2.7.
And so now there's more emphasis on 2.7 than 2.6. So there's an interesting, version control support issue we're learning about through this project.
Yeah, and that's where these communities will benefit from that. So maybe the company doesn't want to support 2.5 or 2.4 even, but the community will.
That's the hope, at least.
Yeah, exactly.
So great. thanks for your efforts. And we'll get some footage, hopefully, on Makers at Amherst Media when we have it actually in some water someplace. And hopefully it will be a pond that doesn't have any trees down. It doesn't get tied up in a bike or something. Well, we'll see. Or maybe that will be our movie, that it's tied up in a bike.
Exactly.
But thanks, guys. You guys are awesome.
Thank you.
And I want to again thank the faculty for the financial support for this, and also M5 in engineering, who's been really a huge help in terms of these guys have been building in their space in the engineering program. So
not just us. So it was,
yeah,
9 people in that M5 on Monday, and there weren't any ECE majors in there.
it's pretty much our class.
Yeah, it was.
Yeah. So M5, thank you for that support. It's really wonderful.